Hello, today we're going to talk about balancing equations. Balancing equations is based off of the law of conservation of mass, sometimes referred to as the law of conservation of matter. The law of conservation of mass, or matter, says that matter is not created or destroyed in a chemical reaction. If I start with 2 pieces of chlorine, I have to end with 2 pieces of chlorine. I can't magically end up with 3, and one doesn't mysteriously disappear to make 2. So in a chemical reaction, the mass stays the same because 2 pieces of chlorine at the beginning and 2 pieces of chlorine at the end are going to have the exact same amount of mass. Chemical reactions are very, very similar to a recipe because a recipe is an actual chemical reaction. If I had to make chocolate chip cookies, I would never put 1 cup of flour and 1 cup of sugar and 1 cup of salt and 1 cup of baking soda and expect to end up with the chocolate chip cookies. Instead, we use a recipe, and the recipe for chocolate chip cookies gives me different amounts of different ingredients because that's what I need in order to make the chocolate chip cookies you're familiar with. A chemical reaction is very much the same. For a chemical reaction, similar to a recipe, we write out a chemical equation. And a chemical equation is basically a symbol equation that tells me what's happening in a chemical reaction. Now, instead of using chocolate chip cookies, which tend to have way too many ingredients, we're going to take a look at a chemical reaction for something simpler. We're going to make a ham sandwich. But I'm going to write this as a chemical equation. So I'm going to write HM as my symbol for ham. I'm going to use a plus sign between that and the bread that I'm using for my sandwich. And I'm going to use another plus sign because in addition to that, I'm going to put on a piece of cheese. And those become my ingredients in my chemical reaction. My ingredients in my chemical reaction are commonly referred to as the reactants. In a chemical reaction, an arrow is used to separate out my ingredients, my reactants, from what I'm making, which is referred to as my products. And what am I making? Well, I'm going to make a sandwich. And for my sandwich, it's going to be bread. But there's not going to be 1 piece of bread. My sandwiches usually have 2. It's going to be ham. And I'm kind of hungry, so let's put 3 pieces of ham on here. But we're just going to put a single piece of cheese. The end report of my chemical reaction is what we refer to as my products. But this chemical reaction doesn't make sense because there's no way I can end with 2 pieces of bread if I don't start with 2 pieces of bread. And there's no way I can end with 3 pieces of cheese if I don't start with 3 pieces of cheese. And this is the concept of a balanced chemical reaction. Now, the important thing about a balanced chemical reaction is I can change the amount that I put in. I can't change my recipe. So instead, we can put a number in front of a chemical reaction that we refer to as a coefficient. And a coefficient changes the recipe. So you cannot change the chemical formula. But I can say, hey, if I'm going to make a sandwich with 3 pieces of ham, I can start with 3 separate pieces of ham. And if I'm going to make a sandwich that has 2 pieces of bread, I can start with 2 pieces of bread. Now, for the cheese, the number 1 is going to be assumed. I wouldn't write cheese if it wasn't actually there. So it is generally not written. And so I don't have to put a 1 in front of the sandwich that I'm creating. A real chemical reaction looks and works pretty much the exact same way. If I have sodium that I am reacting with chlorine, Now, chlorine is a diatomic element. It is never found by itself. It always comes as Cl2. And I'm going to react those to form table salt, which is NaCl. This equation does not follow the law of conservation of matter. In this reaction, I have one piece of sodium, which I'm starting with one piece of sodium and I'm ending with one piece of sodium, so that's not where my problem is. But I have two pieces of chlorine, and I only end with one. And since one piece of chlorine cannot magically disappear, what do I need to do? Well, if it doesn't magically disappear, this equation isn't balanced. So my recipe is wrong. The only thing I can do in a chemical reaction is to change the recipe of the ingredients that I put in. I cannot change this chemical formula and make NaCl NaCl2 because that's not the formula for table salt. So it's really important that you don't change your chemical formulas to balance your equation. Instead, I can change the amount of the ingredients. I can change the amount of products. If I wanted with my sandwiches, I don't have to make one sandwich. I could make two or three. A batch of chocolate chip cookies frequently makes 36 cookies. So I can make more than one piece of NaCl. So the way to balance this if my chlorine doesn't match up is to end with not one piece of chlorine. I can end with two. Now, wait, that doesn't just affect my chlorine because literally a 2 in front of that means I have not one piece of NaCl, I have two pieces of NaCl. And if I have two pieces of NaCl, I've got my two chlorines, but I also have two sodiums. Well, that's okay because I can start with two pieces of sodium. If in order to make this reaction happen, I need to end with two pieces of sodium, I can grab one piece of bread or two pieces of bread or three pieces of bread. I can grab three or two or one sodiums. So this changes and makes it two pieces of Na and two pieces of Cl, and this is a balanced equation. So when we take a look at stoichiometry point 1, we are supposed to be able to balance and describe a chemical reaction using word and symbolic equations. And the whole concept of balancing equations is to make sure that I have the same amount of nitrogen on both sides of the equation, the same amount of hydrogen on both sides of the equation. So I usually create a list underneath my arrow to make those numbers match up. So on this side of the equation, I have two pieces of nitrogen, but on this side of the equation, I only have one. And on this side of the equation, I have two pieces of hydrogen, but on this side of the equation, I have three. There is no right way to begin. You just pick one, and I usually just start at the top. So I have two pieces of nitrogen, and I need two pieces of nitrogen. Again, the only thing I can do to balance this equation is to change the coefficient. So if I want to end with two pieces of nitrogen, I have to end with two pieces of NH3. But that means I have not just one piece of NH3, I now have two pieces of NH3. And while that gets me my two pieces of nitrogen, it also means that I have three plus three is six pieces of hydrogen now. But to balance the equation, then I've got to fix my hydrogen. On this side, I can put a 3 in front of my H2 because I know that if I have H2 and H2 and H2, that gives me three pieces of or six pieces of H2 that I need to balance my equation. The hardest 10 equations that you will balance will be your first 10. So this is something that you definitely have to practice to get the hang of. So let's take a look at one more before I let you try some on your own. So I have KClO3, and for KClO3, that gives me potassium, that gives me chlorine, it gives me oxygen. I have one piece of potassium, I have one piece of potassium. I have one piece of chlorine, I have one piece of chlorine. I have 3 pieces of oxygen. But over here I only have 2 pieces of oxygen. Well, if my potassium is balanced and my chlorine is balanced, but my oxygen isn't, I'm going to have to use a common multiple to make these two numbers the same. And a common multiple between 2 and 3 would be 6. That way I can have the same number on both sides of the equation. So I know that if I have 3 pieces of O2, and that gives me 1, 2, 3 pieces of O2, that's 2, 4, 6. That gives me 6 pieces of oxygen. Now that doesn't affect anything else because O2 is by itself. But over here, if I want 6 pieces of oxygen, 2 times 3 is 6. But if I put a 2 over here, that gives me not 1 piece, oops, that needs to be K, of KClO3. That gives me 2 pieces of KCl3. So that does give me my 6 oxygen, but it also changes my potassium and my chlorine. So if I start with 2 pieces of KClO3, I've got to go back and fix my KCl on the other side. I can end with 2 pieces of KCl, which balances both my potassium and my chlorine, and that makes this a balanced equation. So I need you to stop the video. I want you to try numbers 3 through 6 and come back when you have your answers. So, how'd you do? Take a look at your answer for number 3 and number 4. There's one thing I want to point out with number 5. It is very common to run into hydrogen or oxygen where you have multiple pieces on the same side of the equation. Because these are very common elements, oxygen can sometimes be in this, this, and this, and that makes balancing it a little bit different. For my hydrogen, I have 2 pieces of hydrogen here, and if you ignore my coefficient, I have 1 piece of hydrogen here. So to start, they're separated by a plus sign. I would take the 2 and I would take the 1, and I would add them together. If I have anything that has 2 things on the same side, it's the last thing that I balance in the chemical reaction. If I take a look at number 6, I also want to point out polyatomics. You will frequently run into polyatomics in your ionic compounds. And polyatomics, as long as they stay the same, can be balanced not just as a polyatomic, but they can be balanced as that chunk itself. So instead of breaking this up into sulfur and into oxygen, I balanced the polyatomic sulfate as 1 piece. On this side, I had 1 piece of sulfate. On this side, I had 3 pieces of sulfate. Remember, I'm looking for the number outside of the parentheses for my polyatomics. And so to balance that out, I put a 3 here, and that gave me 6 potassium, so I needed 6 potassium here. That gave me 6 bromine, so I needed 3 bromine here, and I needed to balance it out. Balancing equations is something that's going to take some practice, and you will find a practice sheet in your Google folder to take a look at to get some practice. Try some of the equations in that worksheet. Have a great day.